Okay, in this video we're going to talk about Euler's formula. So the formula, it looks something like this. E to the I theta equals cosine theta plus I sine theta. So I know it's kind of feels random that you can kind of relate like an exponential with cosine and sine, but then I think you've like seen the derivation from the lecture, so I won't go into details here. So we will just see some computations for this formula. So for example, let's do some examples. The first one, e to the I negative I pi. So we want to evaluate this and write it as the usual form of a complex number. So if you look at this formula, it's kind of saying, you know, you have this exponential, but then I can write it as the usual way for a complex number, which is like the real part and the imaginary part. So we want to do that for e to the negative I pi. So according to the formula, so what is theta? Theta is, in the exponent, it's anything except the I. So if you kind of remove the I, then the theta should be negative pi plus I sine negative pi. And then you just need to kind of know the tricks. So I think in this case, maybe, there are several ways to kind of mentally think about it, right? So you can have like one more step. You can say cosine is an even function, so I can forget about the negative. And then sine is a odd function, so I can pull the negative sign out. So then it's negative I sine pi. But then, you don't have to do this step. If you just know the picture of cosine and sine at this step, you can get to the answer immediately. But just in case people are like more used to only knowing things, knowing the tricks for like from 0 to 2 pi, that's like usually the range we're very familiar with. So we like to convert things to between 0 and 2 pi. So then cosine pi is -1, sine pi is 0. So then the answer is just a -1. So I know it's kind of dwelling too much on this simple problem, but I want to remind you that one of the ways I can like quickly kind of retrieve the value for a trig is to memorize their pictures, right? So cosine will look something like this. So that's cosine, right? So that's how I can kind of mentally think of, if pi is here, then the value is -1. Similarly, how do you know quickly sine pi is 0? Is that you memorize this picture for sine. And then, mentally just think about if the input is pi, then it's the y value is sine y is 0. Okay, so let's do more like non-trivial examples. So let's evaluate -4 e to the negative I pi over 6. Okay, so again, we use the formula. So the formula, it only says something about e to the something, right? So I'll just leave the -4 outside and then apply the Euler's formula for this e. So then it's cosine negative pi over 6 plus I sine negative pi over 6. And then, like I said, you can do an extra step. This is an even function, so you can forget about the negative. This is an odd function, so negative I sine pi over 6. And then, so these are the special tricks, right? So So I know, you can, at this point, you can probably write down the values like immediately, but maybe like the trick values the only trick values that I really like keep in mind are probably just like less than a handful. So for example, cosine pi over 6, I usually just remember, let me put a box of like things you definitely need to like memorize. So I like to memorize sine 30 is 1/2 and sine 60 degrees is square root of 3 over 2. And then, every, not everything, you probably want to also memorize like the 45 degree, that's pretty special. That's square root of 2 over 2. So I like to say like all the special tricks, what I really memorize are these like 3, and everything else comes from that. So first you need to know that, if it's like in terms of radians, then pi is the same as 180 degrees. So then that's cosine 30 degree, right? Which is, if you think of a what do you call that? Like a 90-degree triangle, then cosine is just the same as sine if you kind of take the complement of that degree from like 90 degrees, right? So which means cosine 30 degree is sine 60 degree. So then that's why I get the square root of 3 over 2. And similarly, this is 30 degree, so that's the one I happen to just memorize. I know it's probably going through a lot more than necessary. I know most of you can definitely can do this here, but then if you're interested in how to kind of reduce the amount of things you like memorize, you can do this. So then this is negative 2 square root of 3 plus 2i. And that's the usual form that we're used to seeing. Okay, so let's do one more. So e to the I pi over 2 plus I e to the negative I pi over 2. Okay, so we want to evaluate this. So let's apply the Euler's formula. So cosine pi over 2 plus I sine pi over 2 plus I times cosine negative pi over 2 plus I sine negative pi over 2. And then you can multiply this out and then combine like terms. That's what we kind of want to the way we want to like proceed with. So and along at the same time maybe evaluate some of these. So cosine, that's 90. Again, mentally think of the graph for cosine. So then cosine 90 would be 0. And sine 90, again, think of the sine function. Then sine 90 is 1, so that's I. And so this is I times 0. Yeah, that's right, I times 0. And then I times, so this is the key thing. So I times I is negative 1, right? So it's negative 1 times this sine, which is, sine negative is negative of sine pi over 2, which is negative 1. Is that right? Yeah. So then if you just kind of clean up things, it's 1 plus I. Yeah, so I guess, you have many different ways to evaluate something depending on like which formulas you memorize the best and whether you memorize a picture or whether you memorize just like formula. But just try to practice a few more problems to get comfortable. And I'm sure there are like other ways to just based on kind of this like vague symmetry, the problem is design. I'm sure there are like alternative ways to do this, but we want to kind of get comfortable with the Euler's formula in this video. So let's do one more. Evaluate e to the 2e to the I 5 pi over 4. So to evaluate this, so again we can do so maybe in this video it's helpful to kind of deviate a little from the formula. Let's see like an alternative way of evaluating this. So this e, we know that the modulus, kind of the absolute value of this is certainly 1, right? It's just the coefficient in front of this e, which is 1. So then this complex number, e to the I, this radians, this complex number, it corresponds to, you can kind of plot it in an xy plane, right? Where the x-axis is the real part and the y-axis is the imaginary part. So if you think of that e this way, then how do you find a point on this plane? It corresponds to the point where it's certainly on the unit circle because the modulus is 1, but then this kind of degree in radians will tell you where it is. So it's so 5 pi over 4 is 1 pi plus pi over 4, which is if you go like this way, it should be like along this line, and we know the modulus is 1, so which means from here to the origin, that's a distance 1, right? And these are, since it's pi over 2, these are 45 degrees. So then then to write this as the usual a plus bi is just to find the x, kind of the real part, which is the x coordinate and the y coordinate of this point, right? So if you think of it that way, we know this line is 1. So then to get the length of this, it's just 1 divided by square root of 2, because this is a special triangle, right? So then similarly, this length, be careful, I'm talking about length at this point, is 1 divided by square root of 2. But now we want the coordinates, so which means you have to take into account the signs. So this point in the third quadrant, then it's negative, right? So it's negative 1 over square root of 2 plus I, negative 1 over square root of 2. And you want to clean this up a little. So negative 2 over square root of 2 minus I, 2 over square root of 2. You can clean it up a little more. If you don't want the radical in the denominator, then you can multiply by square root of 2 both on top and bottom, and then do some cancellation. At the end, you will get negative square root of 2 minus I square root of 2. So that's another way to kind of evaluate this. So it's not really like using the Euler's formula, but I want you to get comfortable thinking of like an exponential, or we call it the polar form. We want to get comfortable thinking of that as a certain point in the complex plane. Yeah. So and then you write the x coordinate here, the y coordinate here.